All right, welcome to 13.2, the second part of 13.2, which is on arc length and sector area. Now, you should only be watching this if you were in class and we already learned section 13.2. So if you were absent in class and so you didn't learn 13.2, make sure you go back and watch that video first before watching this arc length and sector area. All right, so here's the deal. Anyways, we are going to be taking a circle and we're going to be using degrees and angles to find a sector area, which is part of a circle. And we're going to find something called arc length, which is the edge of part of the circle. So it's basically a fraction of the circle, a fraction of the circumference, I mean. And I have my radius. And this is it might seem kind of random that this is thrown in section 13.2, but it's here because I am using radians and it gives us more practice with manipulating radians and using them in different formulas. That's why I believe they put it in this section. Now, I have some formulas and I'm going to give you the formula in radian measure and degree measure. So the arc length formula, for whatever reason we use S for arc length. So S equals R times theta. R stands for radius. Theta is my angle, and the angle in this formula is in radian measure. The other formula is S equals angle over 360 times 2 pi r, and that is if you have a degree measurement. And by the way, 2 pi r is just the normal circumference formula, so basically what I'm doing is finding the circumference of the circle, and then I'm multiplying it by some fraction representing what fractional part of the circle our piece is. Here's my two formulas for sector area. Area equals 1/2 times r squared times theta, and that is if I have a radian measurement. The other formula is area equals angle over 360 times pi times r squared, and that is if you have degree measurement. Pause video if needed to write down those formulas, and then let's go for it. So when I'm doing these problems, really, if you look at the formulas, the radian formula is the easier formula. So whenever possible, you want to just use that formula. We're not always given radians, though, so that's why I gave you the other version of it. For the example 6a, I am given radians. If it doesn't say they mean radians, they will have the degree symbol if it is in degrees. So let's go for it. So the arc length equals radius times my angle. And as much as possible, we're going to do the exact answer and the approximate answer. So do as much of this as you can in your head just for practice before pulling out your calculator. Because we know if I have 9 over 6, I can divide the top and bottom by 3, and that ends up being 3 pi over 2. So my arc length is 3 pi over 2 centimeters. That would be the exact answer. If I wanted the approximate answer, I'm going to find what 3 pi over 2 is, and it's 4.7. So the approximate answer is 4.7 centimeters. The area, 1/2 times my radius squared times my angle. And I'm writing it kind of funny, but remember, that's really over 1 if it's just a plain number. So 9 squared is 81. 2 times 6 is 12. And before you grab your calculator, think, well, I know 81 and 12 both can be divided by 3. Hopefully. Maybe you didn't know 81 could be divided by 3, but hopefully you knew that. Okay, 81 divided by 3 is 27. So on top, 27 pi. 12 divided by 3 on bottom is 4. So 27 pi over 4 centimeters squared. Notice my labels. Length is centimeters and area is centimeters squared. And if I type that up into my calculator, I get approximately 21.2 centimeters squared. All right, let's go ahead and do B. So I got radius times my angle for my arc length, which is 6 times 4 is 24, 1 times 3 is 3, 8 pi for my arc length. Now maybe that's going a little too fast for you, but push yourself. If it's easy math like that, like you all know what 6 times 4 is and what 1 times 3 is, 24 divided by 3. If you know the math, go for it. Sometimes it's much faster to just do it in your head versus typing it into your calculator. And unless the book says to give it the approximate answer, you can just leave it as the exact answer. I just want you to see that this is not some obscure number. It does translate into an actual distance that I could find. All right, my area is 1/2 times my radius squared times my angle. So 36 times 4, let's see here. And tip, sometimes it's easier actually if I just leave them unmultiplied to start off with. The reason is, I know 4 divided by 2, and I can do 36 divided by 3, that's 12. So now everything on bottom canceled out, so that would be like having a 1 on bottom, and on top I was able to reduce those down to 12 and 2, so 12 times 2 is 24. 24 pi centimeters squared. Alright, so let's talk about what happens when I have an actual degree measurement instead of the radians. You are allowed to convert this to radians if you want and use the radian formula, or I can just use the angle formula, the degree formula I mean. I'm going to just use the degree formula. So for arc length, I do my angle over 360 and then times 2 pi times the radius. Now, be strategic here. 180 divided by 360, cross off the zeros, 18 divided by 36 is a half. So really I have 1/2 times 2 times pi times 10. 1/2 times 2 cancel each other as well. 1/2 times 2 is 1. 10 pi is my arc length. And my area, angle over 360 times pi times radius squared. Again, that is it's the same exact fraction we just used. So that is 1/2, and then 10 squared is 100. Now think about it. What's half of 100? It's 50. So 50 pi centimeters squared. Why don't you pause the video and try a D, and then when you unpause, I'll have the answer showing and we can check your work. Alright, if you have unpaused the videos, here are some of the answers, and now I want to tell you that the one I had you try on your own, these are they're really harder to reduce than the ones I did for A, B, and C, right? So if you're thinking in your mind, I don't know how to reduce that, you are allowed to pull out the calculator if needed. The ones that will be no calculator will be the easier type that you should be able to do in your head, like A and B and maybe C. But D is a little harder than what you would have to do without a calculator. Here's how I would type that in. If I'm going without calculator, 135 divided by 360 times, I know 4 squared is 16, and then it ends up just being 6 in this case. But don't forget about the fraction button. So if I hit math, fraction, I can convert it back to a fraction if I needed to. Now this one I didn't need to, obviously, but you're going to get some funky ones in your assignment. So feel free to hit math fraction to convert it back to a fraction so you can get the exact answer. Now if it, technically you want the fraction form when you do pi, you don't want decimals. Sometimes you see it that way. Usually not though. Let's move on to the word problems. Starting with example 7. The Seattle Space Needle restaurant revolves, making 1 full revolution per hour. The restaurant is circular with a radius of 40 feet. You start dinner at 6:42 p.m. and finish at 8:18 p.m. Through what angle do you rotate during dinner? So now and then I have a second question. How many feet do you revolve? Here's what I gotta say. We know that 1 revolution equals 360 degrees. So basically I need to figure out how many revolutions did I make? Because however many revolutions I made, I'll just multiply by 360 and we'll get our angle. So here's what we got to think of. From 6:42 to 8:18. Okay, and by the way, 1 full revolution per hour. So in my mind, I think, okay, from 6:42 to 7:42, that is 1 hour. Then from 7:42 to 8:18, that actually ends up being 36 minutes. I did some calculating with my calculator there. So I've got 1 hour and 36 minutes. but I'm going to need to put this in a way that I can use my calculator. So in my head, I'm thinking, well, there's 60 minutes in an hour, so I've got 36 sixtieths, 36 minutes in 1 hour. So 1.6 revolutions if I type that into my calculator. So 1.6 revolutions times by 360 gives me 576 degrees total. One plus 36 divided by 60 times 360, 576. Okay, so that's how many degrees. And now how many feet do you rotate? Essentially, they're asking you to find the arc length. So I am in degree measurement, so I'm going to use the degree formula for arc length. Angle over 360 times pi times 2 times pi times the radius, which they said was 40. And now, when you do these word problems, it's fine if you just type that all into your calculator. We're not going to try to find the exact answer for a word problem. 576 divided by 360 times 2 times pi times 40. So 402.1 feet you rotated while you were eating your dinner. Go ahead and rewatch that if needed, but we're going to do example 8 now. Now I have a carousel with diameter 25 feet. It takes 16 seconds to make one rotation. You're riding the carousel for 2 minutes. Through what angle did you rotate? So again, in order to figure out what angle it is, we need to figure out how many revolutions. How many revolutions, and when I figure out, or how many rotations. When I figure that out, I will multiply by 360 to get my angle measure. Now, think about this. I'm going for 2 minutes. How many seconds is 2 minutes? Times 60, right? Because there's 60 seconds per minute. So I rode this ride for 120 seconds. Every 16 seconds, I made one rotation. I'm going around and around and around. Every 16 seconds, I made one rotation. So divide by 16 to see how many times that happened. And it happened 7.5 times. So 7.5 revolutions times 360 is 2,700 degrees I rotated around on this carousel. And then how many feet does a point on the outer edge of the carousel revolve? Again, that's just a fancy way of them saying find the arc length. And I am in degrees, so I'm going to use the degree formula again. 2,700 divided by 360. So angle divided by 360 times 2 pi times the radius. I know the diameter is 25 feet. Radius then would be 12.5. And again, you can just type that all up into your calculator. Give it a try. You should end up with 589.0 feet if I round it to 1 decimal place. That's all. Thanks for watching. Have a great night.